In this recording, we're going to expand your mathematical horizons and look at systems of linear equations with 3 variables, not just 2. So at first glance, this looks crazy, right? You've got x's and y's and z's. You were just starting to get comfortable with the kind that had x's and y's, right? So in this system, it has 3 unknowns and 3 separate equations. Let's think about what that solution might look like by first going back and looking at solutions to the easier equations we once upon a time were able to solve. So in our original type of equation, just has one variable, you're just going to have one solution, like x equals 3, and you can plot that on a number line. If you have 2 variables, two equation system with x and y as your variables, you can plot that on a coordinate plane, right? -2, 3. A 3 variable system is a little more difficult to draw, so I'll show it with this applet here. So if I had the solution that happens to be 2 for x, 3 for y, -4 for z, watch what happens when we plot it. It goes 2 in the x, 3 in the y, and down 4 in the z. It's like having a third dimension, right? You're not just living in a flat world, you now have a third dimension. So it went 2 for x, 3 for y, and down 4 for the z. All right? So let's go about how to solve an equation of this sort. A little complicated. We'll do one together, and I'll give you one to do for practice. So in this case, it's going to kind of hold our hand to work through this problem. All right, so we're going to first look at our system here and say, do we have any relationship among the variables? And as you can see right away, hey, I've got this 4z and its opposite, -4z, that I could work with. So it says, use those 2 equations, 2 and 3, to eliminate the z variable. So let's do just that. When we add these 2 equations, remember I'm adding a 7 to the right side, and on the left side, I'm adding something that looks totally different from a 7, but because of the equation, the equal sign, we know it is. So I'm just going to take these 2 guys, bring them down here, and write what their solution, their sum would be. So 5x, try one more time, 5x plus 6y, and then I don't have any z's because those are opposites, equals 12. Okay? Now, in part B, it says, using equations 1 and 2, you can eliminate the variable z. Well, unfortunately, I don't have the exact opposite here of variables, so of coefficients. So let's grab those 2, bring them down here, and I'll rewrite them. So I've got x plus y minus 2z. It's helpful to make your z's with a little line through it. Otherwise, it starts to look like a 22. And then my second equation, 2x plus 3y plus 4z equals 5. Now, what I'd like you to do is, on your own, come up with a way to eliminate the z variable. What are you going to multiply one or both equations by? Pause. Play the recording when you've done some work. Okay, so hopefully you paused and did some on your own. Hopefully you recognize, hey, I can get this situation to eliminate the z's if I get this coefficient of z to be a -4. So I'm going to multiply all terms in the numerator, and not in the numerator, in the first equation by 2. Just because it's the top doesn't make it a numerator, right? And that's going to lead us to a top equation, equation that has 2x plus 2y minus 4z equals 10. Of course, the second equation is just as it was. Just copy that. And we've created opposite coefficients of our z. That's good news. We can add and eliminate the z's. All right, so those add to 0. And even though we're not eliminating the x's or the y's, that's okay, because we've done something. We've at least gotten rid of one variable. Okay, and so I've created an equation here that just has x's and y's, an equation here that has x's and y's. Hey, you know what to do with that, right? You've done equations of that sort before. 2 equations, 2 unknowns. So that's what part C says to do. Just work with those 2 equations and solve for x and y. So let me give you an opportunity to do that. Play the recording when you've done so. All right, so hopefully you took time to pause and work out this system on your own, the one that has 4x plus 5y equals 15 and 5x plus 6y equals 12. If not, do that now. Okay, here's the solution. All right, you're going to do anything you can to get one of these variables to have opposite coefficients. I chose the x's. 4 and 5 don't have common factors, so I just kind of multiplied each one by the other, and I've got 20x and negative 20x. Works out to be y equals 27. Sub that in for y, x equals negative 30. Now before we'd be finished, right? We found the values of x and y. Fortunately, this one is not finished because we haven't found z yet, but we're really close. So go ahead and pick any of those 3 equations, as it says in part D, any of them. Sub in your x, sub in your y, solve your z. Piece of cake. Pause the recording, play it when you're ready. So I'm just going to sub in to the top equation. I've got negative 30 for x, I've got 27 for y, and then I've got a minus 2z. That's all equal to negative 5. All you got to do is solve that for z. So let's just combine some like terms here. I got a negative 3 minus 2z equals 5. Negative 2z equals 8. That means z is equal to negative 4. You're going to write that as an ordered pair, an ordered triplet or triple. Not an ordered pair. That would only be 2 variables, right? So we've got the first one, which is x, negative 30. The second variable y, which is 27. And the third variable z, which was negative 4. And if you remember, we showed on that applet how that could be plotted, right? X and y are the same as before, but z is going up and down out of your paper. It's like an axis jumping out of your desk in the 3rd dimension. If you have your own graphing calculator, why don't you try this now? You can store any number in any of the letters that are available for variables. So I don't know if you've had the experience before of storing a number in x, but it's pretty straightforward. I've already stored the x and y values. I'll show you how to store the z, and then you can try it on your own. So for z, I'm going to store negative 4, so I'm going to type in negative 4. Be careful to use the white negative key, not the gray subtraction key. Then I'm going to hit the stow button just here on the left, and then I'm going to hit alpha, and I'm going to scour this screen for the green z, which is right above the 2 button. So now it's stored. And now that x, y, and z are stored with their values, I'm going to type in one of the equations. So I'll type in the first one, x plus y minus 2z. So minus 2, and the alpha for the z. And this should equal 5 if I've done my work right. And then I can proceed to use the same process to check the second and third equations and make sure they work out as well. Now for our final practice, we've got this pretty challenging problem here that I'd like you to get as far as you can, doing any work that you can to try to eliminate one of the variables. I won't tell you which one you have to do first or anything like that. Try to follow the process used before to eliminate one of the variables, either x or y or z, and then try to put those 2 equations together that you ended up with after you eliminated one of the variables, and solve that system. And then once you know 2 of the values of the variables, you can sub in for that third one. All right, so I'll leave you to your own work. Pause and play the recording when you've got some work. All right, so I'm hoping you got a little bit of work done here. What I chose to do was eliminate the x's. So I multiplied in the second and third equations. I multiplied the third equation by negative 1 so I could get the x's to be opposite signs of negative 2 and 2. Okay, that gave me one equation that involves y's and z's. So I need to look at another pair of equations. Doesn't matter which 2. I could go with first and third. I happen to go with the first and second. Okay, and in that case, what I did was rewrite over here in blue the first and second equations. I wanted the x's to eliminate once more, and so in that case I multiplied the top by negative 2. So oddly, it also eliminated the y's, which is actually pretty handy for me because now I just know that z equals 4. Okay? See if you can take it from there to find out what y is. Okay, so hopefully you paused and worked out to find out what y is. You just sub z in. All right, sub it in here. It's 4. Work out y is 3. And then you can sub in to any of the equations. I went with the first one. X plus the value of y and z equals 5, so x equals -2. You can certainly sub into your calculator and check, or you can sub them all in by hand. Thanks for watching.